Hey everybody, today we're going to write an exponential equation given a table. Today we're going to see a bunch of tables. I just want you to focus in on this word because I'm not going to repeat the direction every single slide, or it's not going to say it on every single slide. We're writing an exponential equation for every single one of these. All right, let's get to it. So we're writing an exponential equation when we look at this. First off, that adds 4, then it doesn't add 4, so we know it's not linear. So we know that it is exponential. Some of you might be able to figure this out, trial and error, guesstimate, estimate, things like that. If you know that it says exponential, which again, I didn't really write here, but if we know that the directions say that it's exponential, that means that we are multiplying each time. We are multiplying each time. So you can simply divide backwards 12 divided by 8 to see what the multiplier is. You can do 18 divided by 12 to see what the multiplier is. So when you do that, you don't have to guess or check. So again, exponential means that we are multiplying. If you can't figure out the number in your head, which is totally okay, just divide backwards and it will tell you that the multiplier is times 1.5. The multiplier is times 1.5. And that makes sense. As we get further, we actually start to see that decimal when we get half of that odd number right there, that 27. Half of an odd number is going to give us that decimal piece. So we're multiplying by 1.5 here. This problem is lovely because it gives us our y-intercept, so we go right to our equation of y equals our starting point or y-intercept of 8 times 1.5, and when we multiply, shout it out, we get an exponent up there. Cool, that is really it. What I'd like to make a mental note of just for later is that the form of an equation, which I don't do too much stuff on forms or formulas, but it is y equals a times b to the power of x, where a is your start, a is your y-intercept, a is your 0th term. We've talked about this when we just did geometric sequences. B would be, I guess I could say pattern, but we know that the pattern is not adding. I mean, it clearly says times B, so a better word might be like the multiplier, or you might see in some books that it's called the ratio or the rate that it multiplies by. So we'll be referencing that a little bit, but really our answer is the starting point of 8 times 1.5 to the power of x. Cool, what's different about the next one? 0's missing. That's fine, we don't need it yet. That would be our a value on that formula that we just were filling out, the a times b to the power of x, but I could figure out the b. I could figure out the pattern. What is it multiplying by? What is it multiplying by? Again, I didn't write the directions, but the directions would say find the exponential equation. So we know that it's multiplying. I definitely don't know what this is multiplying by with these decimals. So all I'm going to do is I'm going to divide backwards. 4.68 divided by 23.4, and I get 0.2. 23.4 divided by 117, and I get 0.2, which makes sense because that number is less than 1, and what happens when you multiply by a number that's less than 1? It decreases. Again, all that I'm doing, I'll show it here because I have a calculator off to the side, is I just took 4.68 and I just divided backwards to the 23.4, and that gave me the multiplier. I took 23.4 and I divided backwards to the 117, and that got me the multiplier. So my multiplier is times 0.2. I now need the starting point, so let's go ahead and divide backwards. The same thing, hey, right? Same thing. If we need to figure it out, divide backwards. We need the 0th term, let's divide backwards. So all I'm typing in is 117 dividing by that 0.2 backwards. 117 divided by 0.2 is, I can't do that one in my head, 585. Put it in the table if you need to, but really that's going to help us make our equation. Y equals 585 is our starting point, or our y-intercept, times 0.2 to the power of x. There is our exponential equation. All right, we got some gaps filling in here. Again, we can mentally guess. We can trial and error. We know that it's exponential, so it's multiplying times something. Watch this idea out. This one doesn't come in any book. Ready? Start at 4, It's multiplying by something because it's exponential, it said that. And then it's multiplying by that same something again, and that gets us to 36. I just made an equation out of a weird gap in a table, right? But I'm understanding that it told me it was exponential, so I know that it's multiplying by something. Instead of just guessing and checking, let's now go ahead and solve this equation. Divided by 4. We can do that. M times m, that's m squared. 36 divided by 4 is 9. Do you know how to get rid of a squared? You square root it. So square and square root cancel out, and the multiplier is 3. Could we have guessed that? Probably, right? A little bit trial and error. We know that our multiplier is not times this random m, but it's times 3, which would get me to 12. And then it's times 3, which would get me to 36. And then 36 times 3 is going to get me to 108. And then 108 times 3, I hope, would get me to 324. 108 times 3 is indeed 324. Cool, I have all the information I need. You ready? Y equals our starting point. There it is, 4. Times our multiplier. We solved it, and then we checked it. Times 3 times 3 times 3, that leads to an exponent. We now have an exponential equation. Cool, sound good? I'm going to teach you a different way. This is the way that our book teaches it, but 4 times 3 to the power of x. I'm going to go ahead and erase my work, but I'm going to leave that little note there. Let's go back to the beginning, and I'll highlight in red. Let's say we just had this. We just had this. We just had this one, right? What if I took y equals a times b to the power of x, and I filled in like this piece of information? Well, what does that piece of information say? It tells me that 4 is the x value, and it tells me that 324 is the y value. All right, cool, Mr. Z. There are 2 variables. We can't solve for 2 variables unless we have 2 equations. We know we did this back a couple chapters ago when we were learning about systems. We did elimination and substitution and graphing and equal values. I need a second equation. Let me go ahead and take this second point. Y equals, I have a y value. It is 36. A value, I actually do know my a value here, but I'm going to pretend that I don't. My b value, I actually know. We did the work, but I'm going to pretend that I don't. And then a times b to the power of x. What is my x value? It would be a 2. The 2 matched up with the 36. Watch this little strategy for elimination. We have multiplication, so I'm going to go ahead and toss in one big division sign. What is 324 divided by 36? Our calculator tells us 9. What is a divided by a? That is 1, or it cancels out, so I don't need it in the equation. 1 times anything is still going to be itself, so we have canceling out there. Let's go back to our exponent property. So now we're combining our chapter on systems with our chapter on exponents. What is b to the 4th over b to the 2nd? Well, we have canceling. That's a 1, that's a 1, and we're just left with b squared. How do we solve b squared? Oh, this should look familiar. We square root, and our b value is 3. Hey, look, our b value is 3. Our 4 is our starting point, or our a value. We have the same equation. Do whichever one makes sense to you, right? Doesn't matter to me. Let's go ahead and try this out. Oh, yikes. We do not have a table. What is 0? What is 1? Oh, we do know, 80. What is 2? We don't know. What's 3? We don't know. What's 4? It's 10. I see that it's decreasing, so my multiplier better be less than 1. Well, I could probably guess, right? But how can we actually get there? All you do is you take y equals a times b to the power of x, and you fill in. Like, oh, I have a y value here, so I'm going to fill in 10. I don't know the starting point, a. I don't know the pattern of b, but I have an x value. Ooh, it's 4. It matches up. Let's do that same exact thing, but now for the other point. Do we have a y value? We do. Do we have an a value, a start? Nope. Do we have a b, the pattern, the multiplier? Nope. Do we have an x value? Yep, we do. That is a 1. Watch this little trick. Divide that whole shebang. What is 10 divided by 80? I type it in my calculator and I get 0.125. What is a divided by a? That is 1. They cancel out. What's b to the 4th? Over b. That would be b to the 3rd. We haven't done this yet. Guess how you solve a b to the 3rd? Well, we solve b squared by taking the square root. We can solve b to the 3rd by taking in the 3rd root. We will do this in class, but if you are ahead of the game, ahead of schedule, come see me, come talk to me about where to find that on your calculator or where on Desmos. If you are on Desmos, it's in the functions menu. If you are on a graphing calculator, you can often find it in the math menu, or it might look like a little button like that. But I'll go ahead and save that for another day when I can have you in person. Right now, I'm going to go ahead to my math menu, type in the 3rd root of 0.125, and it tells me that the b value or the multiplier or the pattern is 0.5. So what happens when we go times 0.5? What happens when we go times 0.5? What happens when we go times 0.5? Or we could divide by 0.5, and that would help us figure out our equation. Are you ready? Y equals our starting point of 160, our pattern or b value of times 0.5. And when we multiply, that is an exponent. Alrighty, who wants to do that a different way? I heard some people in the back of the class, in the back of the audience yelling it out. Ready? Let's go back here. What were we given? We were given 2 points. How do we get from 80 to 10? We're going to multiply by something because it told us exponential to get to that second point. We're going to multiply by something to get to that third point, whatever it is. We're going to multiply by something to get to that fourth point. I'm going to take this and turn it into an equation. 80 times m times m times m equals 10. Let's get the m's by themselves. Divide by 80. We have m times m times m. Let's shortcut that to m to the 3rd. We have 10 divided by 80. Does that sound familiar? I hope so. 0.125. How do we solve a 3rd power? We're going to take the 3rd root. And we will get our multiplier. The 3rd root of 0.125 is our multiplier of 0.5. Which way do you prefer? Do you like taking two equations and eliminating them? Do you like making up your own equation from the table? Again, you might not see that second strategy in a book. Watch this one right here. We need to actually get from 4 to 1024. We need to get from 4 to 1024. What's happening? Well, it tells us it's multiplying. It's exponential. It is going a gap of 4 numbers from 2 to 6. You want to see that on a table? Let's do it. 0, 1, 2, there's that point. 3, 4, 5, 6, there's that point. We would need a multiplier to get to the 3rd number. We would need a multiplier to get to the 4th number. We would need a multiplier to get to the 5th number. And we would need a multiplier to get to that 6th number. Do you see how there is m to the 4th right there? M times m times m times m. All right, let's go ahead and use it. Let's go ahead and get rid of that regular 4 first. That coefficient, divide by 4, because it said times by 4. So we have m to the 4th equals 1024 divided by 4 is a 256. How do we get rid of a 4th power? We take the 4th root. Again, I will teach you that, or you can look it up on Desmos or YouTube. We're going to go ahead and take the 4th root of 256, and we get the multiplier is 4. How can we use that to help us out? Times 4. What's 16 times 4? 64. Times 4. And we get 256. What's 256 times 4? 1024. Check. Let's go backwards. Divide by 4. 4 divided by 4 is 1. 1 divided by 4 is 1/4 or a quarter or 0.25. We have all the information we need. We have our beginning. Y equals 1/4 or our beginning times our multiplier times 4 times 4 times 4 turns into our exponent. Okay, that was a lot. I know I went fast, but I promise if you're in my class, we're going to do more examples in class, but hopefully that gives you what you need. You can rewind it, you can pause it, you can slow it down. It gives you different strategies. guess what? Let's go overtime. Let's go bonus. Let's make that money. All right, let's go ahead and take a different strategy. We did it before. Y equals A times B to the power of X. Let's just fill in some numbers. I always like using the second point. It's normally bigger. Do I have a Y value? Yep, 1,024. Do I know the starting point, the A? Nope. Do I know the B, the pattern, the multiplier? Nope. Do I know an X value? Yep, it is 6. So I just turn that point into the equation. Let's go ahead and turn this point into the equation. I have a Y value. I don't know the A. I don't know the B, but I have an X value, which is 2. I can't solve for 2 variables unless I use elimination in that second equation. What is 1024 divided by 4? That gives me 256. What is A divided by A? That's 1, or it cancels out. What is B to the 6th canceling out 2 more B's, or B to the 2nd? That is B to the 4th. That equation should look familiar. Let's go ahead and take the 4th root. The 4th root. What is the 4th root of 256? Again, does this sound familiar? We already did it. It is 4. 4th power and 4th root cancel out. We get our B value, which is our multiplier right there. We can multiply by 4 in the table, or we could take this second point right here and divide by 4. And we can divide by 4 again, and that will give us our starting point, or our y-intercept. You could call it a decimal, a fraction, whatever you want. There's that bonus time. There's a bunch of strategies, a bunch of examples doing it multiple ways. I know it's tough. This is maybe the heaviest duty. I don't know if that's a word. Heavy duty, the most heavy duty math you might be doing in this class this year. So congratulations. We know how to make exponential equations when we have tables or points.